Welcome to the second video in our series covering health and safety here at Unix Line Pte Limited and TM Ship Management Co Limited. In this video, we'll be looking at hazard identification. The hazard identification tool we use is based around the energy source concept. The process is very simple. You identify what energy sources are present in your workplace and analyze if they have any potential for causing harm. In the shipping industry, we're exposed to all of these energy sources almost all the time, so hazard identification is essential. But firstly, what is a hazard? A hazard is a condition or action that has the potential to create unwanted contact with an energy source, which may result in harm or injury to people, property, or the environment. Energy sources. We need an energy source to do our work, but sometimes an unplanned release from an energy source can have unwelcome results, including property damage and injuries. For the purposes of hazard recognition, we separate energy sources into 10 groups. We will use this tool to identify hazards within each group. Gravity. Gravitational force is present all the time. Anything high up or being lifted up has the potential to fall down. This could include suspended loads, a tool used on a scaffolding platform, or items stacked too highly. Slips, trips, and falls due to gravity are very common causes for injuries on board ship. Motion. Motion is another energy source which is present pretty much all of the time. For example, rolling and pitching at sea, lifting operations, and even our own movement could be a potential hazard. For example, using an incorrect posture when lifting heavy items can cause you injury. Mechanical energy. Mechanical energy is typically created by machinery, such as the rotating shaft of a motor or a grinder's rotating disc. These produce quite recognizable risks, such as getting fingers, hands, clothing, or hair caught in gears, blades, or other spinning objects. A less evident example of a mechanical energy is the compressed spring. It's not moving, but has the potential to move and release its stored energy with great force. Electrical. Electrical energy is very common all around us. We use equipment which generates, stores, transfers, or consumes electrical energy. Direct contact with electricity and electrical energy can be fatal. Risks include short circuits, water damage, cutting through live wiring, and poorly earthed equipment. Pressure. Liquids and gases are usually stored under pressure, and any unwanted contact or uncontrolled release of this pressure can have serious consequences. Typical hazards include the risk of tank punctures, faulty valves or hoses, and overpressurized containers. Temperature. Very high or very low temperatures can cause harm to humans and damage equipment. Exposure to extreme heat can lead to heat stroke, while extreme cold can result in hypothermia. Heat can generate sparks or smoke that potentially leads to fire, particularly where flammable mixtures or materials are present. Chemical energy. Chemical energy might be the broadest energy source we deal with. Our fleet vessels carry many types of hazardous chemicals. They could be flammable, toxic, or highly corrosive. Strict compliance with safe handling procedures is required to prevent harm to people, environment, and property. As well as the cargo we carry, we need to identify the other chemical hazards on our vessels, such as welding fumes or working in oxygen-deficient atmospheres. Even simple cleaning products can emit flammable vapors or toxic compounds if not used correctly. Biological. Food is a form of stored energy, and there are significant hazards associated with improperly handled food or contaminated water. Biological threats can also come from bacteria, viruses, insect infestations, and bloodborne pathogens. Living in close quarters on a vessel means good hygiene and minimizing disease hazards are a top priority. Radiation. Radiation occurs in two basic forms: non-ionizing and the more dangerous ionizing radiation. We come across non-ionizing radiation almost every day, including the sun's rays, radio waves, and microwave energy. Hazards like sunburn and the risk of skin cancer need to be acknowledged by those working outside. Ionizing radiation includes X-rays and exposure to radioactive material, and the potential for harm is much greater. Sound. Sound-related hazards include equipment noise, impact noise, and vibration. Very high sound levels or continued exposure to noisy environments are obviously hazardous to your hearing, and proper hearing protection should be used at all times. Less obvious is the influence of noise levels on communication, leading to misunderstanding and potential human error. The presence of an energy source doesn't mean a hazard exists, but the greater the energy source, the bigger the risk of potential hazards. Ranked in descending order of effectiveness, the following control measures can be used to mitigate the risks associated with any energy source. The number one control solution is to remove the energy source, to prevent and protect from a release. For example, by switching off the electrical power supply to equipment and using lockout or tagout procedures. Secondly, you can substitute it with safer alternatives, use less hazardous chemicals, or use approved material handling equipment. Thirdly, you can limit energy by reducing speed, lowering operating temperatures, or reducing pressure levels. The next best thing to do is provide barriers around the energy source, such as electrical and thermal insulation, guardrails, containment systems, detection sensors, and shutdown devices. Lastly, to protect from a release and potential contact with an energy source, provide personal protective equipment to everyone who needs it. This includes items such as safety harness, lanyards, SCBA, chemical suits, aprons, and goggles. Quite often, it's the interaction of two or more energy sources that leads to an accident or makes the consequences more severe. The most common example of this interaction is an ignition source in the presence of flammable vapors, leading to an explosion and fire. The hazard identification process needs to account for this interaction between energy sources, as many incidents can be attributed to a combination of unexpected factors that only seem obvious in hindsight. Thank you for watching this video, and remember, watch out for your fellow crew and stay safe.